Hello, everybody. My name is John. Welcome to the Munro Live Podcast. And today with me, I have the pleasure of talking with Rob McGinnis. He is the CEO of Prometheus Fuel. Rob, could you give the audience a little bit about yourself and your background?
Yeah, thank you. My name is Rob McGinnis. I'm founder and CEO of Prometheus Fuels. And this is my third startup company. I did my PhD in chemical and environmental engineering. And I started, excuse me, my first startup company out of that program. And that was in desalination. And then I started a second company, was in separations. And then, excuse me, this company is really exciting because what we do is we make fuel out of air and electricity.
I think that's very cool. And it's obviously, to me, it's unique, and probably to a lot of the listening audience that will listen to this might find it unique. So I think where I want to try to go with this conversation is explain the uniqueness of it and the passion that you have for it, along with any special notes that you might want the audience to take away from this conversation as we talk, as the talk unfolds, and how it will change their lives, because I think it will really change the lives of people and, of course, the planet.
Yeah, for sure. I mean, this is a major transformation. It's a big deal.
It is. So when you look at how you create fuel out of thin air, can you break down those components for us, please?
Yeah, I mean, so one way to think about it is like reverse combustion. So if you're driving your car, you have fuel in the tank, and it is combined with oxygen from the air, and it turns into power, right, at the wheels. And then what comes out of the tailpipe is CO2 and water vapor. So what we do is essentially go in reverse. So reverse combustion. What that means is we take CO2 from the air, water vapor from the air, or from just a water source, and we put power into it from, say, solar panels, and turn those back into liquid fuel again. And so that allows you to do a bunch of things that we haven't been able to do before. Before this point in time, if you wanted fuel, you had to, or energy, you had to dig in the ground for it, right? I mean, that's essentially what we do. Starting out in the oil industry, they used to just take rags and like get into like, ponds that had oil in them and wring it into barrels and stuff, right? It literally was just getting it out of the ground. So this would be like the first time when you can make like a liquid fuel you can run an airplane on or a ship on, that you didn't have to dig it out of the ground. So essentially you can choose to make it wherever and whenever you want, out of electricity. So if you have like a spot of land, you could just decide, I'm going to make fuel here.
Yeah, that's really cool. I also read that, obviously you make fuel, but you can also use it to make materials. You can use it for spirits as well. I find that fascinating. So how long is the process from the time the fan draws in the atmospheric CO2 to the time it comes out as fuel in your system?
So I mean it's just a few minutes. So the CO2 is captured out of the air into water, and that water is kind of continuously flowing in a loop between that, what we call it a direct air capture tower, right? And that goes to our electrochemical stack. It's actually the first of a kind. It's a hydrocarbon electrolyzer. So it makes hydrocarbons. And so the CO2 we capture in the air comes to the stack, gets turned into fuel in the stack, and then the water goes back to get more CO2. It just goes in a loop. They're tightly integrated, actually, two halves of the same system.
Net zero carbon fuel producer. I think that's really cool. Now, somewhere in that process, you mentioned extraction. Is that part of the Faraday and the Maxwell core aspects of it?
So we have something called the Maxwell core that we can use to separate out alcohols. So if we want to make, like you mentioned, spirits, right? That'd be ethanol. That's the one we're all familiar with. It might be the more popular application actually down the road, but you essentially could set up anywhere you want and pull CO2 out of the air and turn it into whiskey if you wanted to. And to do that, though, you want a certain concentration of that alcohol. And so water and alcohol are kind of hard to separate. Typically, you'd have to do something called distillation, which is not that efficient. It's a really, really old technology. It's one of the first chemical engineering technologies, but we've got a membrane that can do that job a lot better. And so when we make something like a methanol or an ethanol or one of the other alcohols you can make, things like rubbing alcohols called isopropyl alcohol, we can make that too. You want to separate that out with a membrane, and that allows you to use just electricity and to have your system be real lightweight and containerized and be wherever you want it. But if you're making something like a kerosene or a diesel, then that just flows to the surface of the water, and you can just pour it off the surface. You don't have to do anything to get it, because those things don't like to be together. Diesel and water don't mix.
So everything is designed, I think, to fit on 40-foot containers for transportation. Is that correct?
Well, there's two kind of ways we'll build this. So if you want to have like a desert island and you want to have your own house there and you want to fly your helicopter in and out or whatever, it'd be a 40-foot container, and you'd make your own helicopter fuel, and you'd make your own, you can make your own propane for your stove and hot water or whatever. You can be completely off grid and still have heat and fuel, right? Or maybe you just want to take a fishing boat out. That's container, right? But if you're going to make these fuels at very, very large scale, millions and millions of tons of fuel per year, then it'll be more like putting these Faraday reactors, which are, we have some pictures of them up on our website. It's an electrochemical stack. It's made out of plastic. It's about, a meter wide. I can't show my hands on the screen, but it's designed to be the size that like two people could move around, or you can move the forklift essentially. And you put just a bunch of those in a warehouse. And so we would call that a Titan fuel foundry. And if we make the 40-foot container, we call it a Titan fuel forge. And that's just a cool name we have for it. Titan refers to the Prometheus myth.
How long does it take to put together a forge?
It's, right now it's engineers building by hand, right? Because but the idea is you mass manufacture these things. So the stacks are made out of plastic. And so you can use a process called injection molding. And so you make like a steel cast, and then you can essentially shoot plastic into it to make the piece. And you could do just hundreds of thousands of those per casting. And the cost of doing that is so cheap. I mean, if you're doing it at volume, it's like 5% over the cost of the plastic itself. And if we're using polyethylene, it's about $1 a kilogram. And so it's very, very inexpensive. And what you do is you automatically assemble those plates together. So every stack is made up of cells. Any kind of electrochemistry tends to have like the same characteristics, whether it be a battery or a hydrocarbon electrolyzer. They have a cathode and an anode, and some kind of separator in between the two of them. So you can have different reactions on either side. And so these things just get assembled just like a battery does into a stack. And then you put a bunch of stacks into a building or into a container, and you've got your basic package. There's a whole bunch of other things like some pumps and some pipes and stuff, but it's all atmospheric pressure and room temperature. So we use like PVC pipes. I built my first system with a lot of stuff I got at Home Depot.
Okay.
Some specialized
Smart.
parts too, obviously. Yeah. Some special pieces, but a lot of the plumbing was just like go to Home Depot and get it, Yeah.
And
I'd go like eight times a day to go get parts.
They got to know you pretty well back in the day, huh?
They did. They're like, what are you building? Like, you wouldn't believe me if I told you.
I read on your website, and by the way, before I go any further, I want to comment on your website. It's spectacularly awesome. It's very intuitive, and it's very interactive. So you and your team have a wonderful product out there with your website, and I would encourage anybody to go to Prometheus Fuel, or is it fuels.com, and check it out. It's very cool.
Thank you. Big shout out to Amanda Martinez, our head of brand, and her team for working with some web designers, and they came up with the concept and the storyline and the whole thing, and it really kind of won a bunch of awards and kind of broke the norms around what a website should look like.
Yeah, and the thing is, your storyline breaks it down at the elementary level, so anybody can read it and understand where you're going with this technology. That only really helps your cause overall at the end of the day.
For sure. It's new, and so it's important to be able to try and explain it and show how it fits in the world, for sure.
So where I want to go to next is like when you want to start building these at scale, and hopefully that's going to happen very soon for you and your organization. You have what you call a meta forge. Is that just something that is basically a facility that builds a lot of these forges, the Titan forges? That's
right. It's a manufacturing facility. So the idea is to build these the way you build cars or any kind of mass manufacturing component, because that's another, just like injection molding, the whole system ends up being, very inexpensive if you're making a lot of them in a standardized way. And we can do that whether it's for the forges and the containers, or we can do it for the foundries. And we call it Metaforge because it's a forge that builds forges, right? So it's everybody wants to name their factory something cool.
Yep, yeah, that's a pretty cool name. Exactly, I like it. It's catchy. It very much is. So really, what we're talking about is we're taking the exhaust from vehicles, for example, the CO2, and we're capturing that. We're turning it back into fuel. So it's carbon neutral. and which is extremely cool. Have you had any challenges trying to get your messaging out there with perhaps people that are reluctant to accept this idea in any form or fashion?
No, I'd say it's just that it takes a while to tell people about something new.
Yeah.
I mean, so there's this category of fuel called e-fuels that other companies have been pursuing, but it's not nothing like what we do. And for most people, kind of casually reading about it, it's hard to tell them apart. What everybody else has been trying to do is using technologies that really are 100 years old or 50 years old, and trying to dust them off and see if they can sell the fuel from it, even though it costs $10 a gallon. From the very beginning, we were going for lower price. We want to compete with fossil fuels on price. So it's actually just a completely different category of thing, even though people sometimes refer to us as e-fuels and them as e-fuels. And so part of what I have to do is go out and kind of say, hey, not only do we make it a new way, but it is just a new thing. I mean, so it's as important to be able to make your own fuel anywhere you want from electricity as some of the greatest, I guess, industrial technologies in our history. I mean, if you think about the steam engine,
Yeah.
the electric light bulb, flight, I mean, these are all things that changed the world because they created new business models, because they gave people new capabilities. And I think 50 years from now, we're going to look back and we're going to be in disbelief that we used to dig in the ground to get energy.
Oh, I would imagine so. Just like as so eloquently stated on your website, where certain people, notable people, were completely dead against heavier than air flight, right? And,
yeah, that's right.
You have a nice storyline for that too, by the way, on your website. It's really neat.
There are lots of stories of what people introducing these new technologies kind of had to go through to tell people about them. It hasn't been easy, to demonstrate your light bulb or to show off your new flying plane. Like you have to try for a while to tell people about it.
Yeah, I think it's important to also emphasize that with your fuel, it works in any standard. For example, if I want to put it into my Chevrolet Silverado today, I can put it in there today and I can run it just as well. And it's probably more efficient than the standard fossil fuel. Is that correct? It also will burn cleaner.
Yeah, much cleaner. So the thing about fuel is they're made up of hydrocarbons, and there's this whole field of chemistry called organic chemistry that some people have to go through and most people avoid. Excuse me. If you break down what's in gasoline, it's got hundreds of different molecules of different types, and we have kind of standard categories for them that kind of bracket it in so that it's going to run well in your car. So we can make those molecules, right? We know how to make it. So one of the ways you differentiate between gasoline or jet fuel or diesel is the number of carbon atoms it has in a molecule. So gasoline will have between 4 and 12 carbons, and jet fuel is between like 8 and 16, and diesel is between like 8 and 20. And then really heavy fuel oils that you might use on a ship can go up to 50 carbons. So we've been able to make everything from 1 carbon to more than 30 in water at room temperature, atmospheric pressure in this new process. And this is just mind blowing to anyone who studies kind of the history of organic chemistry. To be able to just synthesize these fuel molecules is amazing. Now, turning those into something they can drop into your Silverado requires us to do a bunch of secondary stuff, like we might want to add a detergent or add in a lubricant or add some bunch of additives and things like that, and make sure we get the vapor pressure just right and these sort of things. So this is what we're working on now. Is we're introducing our first product, which is a simple fuel called methanol. Right, we drive our '68 Mustang Fastback on it. You can use it. You can race on it. You can drive ships with it, and you can actually turn methanol into gasoline, diesel, and jet fuel. But as we introduce more fuel types, as we go in and we start introducing things like renewable natural gas made from electricity, or as it goes, start making ethanol made from electricity, we start making gasoline and diesel made from electricity. We're going to make sure that they drop into your engine the right way. And what a lot of people don't think about is the fact that different times of the year have different formulations of gasoline. It gets really, really complicated. If you're trying to start your engine in Minnesota in the winter, you want a different blend than if you're down in Florida during the summer, right?
Oh, really? So it goes beyond the octane numbers then.
Oh, yeah.
There's stuff going on behind the scenes.
All that stuff. So oil and gas industry has done an amazing job over the last 150 years of making specialized blends, but this stuff that you use in our cars and trucks now came literally from the ground. It's got a bunch of junk in it. And so it's if you ever get behind a diesel truck, it smells pretty bad. There's a lot of soot. Our fuel is synthetic. It's made, from scratch, and it's much cleaner. Especially with something like a methanol fuel. If you stand behind the Mustang revving it, it smells like nothing. It smells like just power and air.
So when you add the special additives to make the certain blends of your fuel, is that all done in the forge itself?
So we'll probably do things like, blending in. Like if you put in an additive, it might be like 0.1% or something.
Okay.
And you probably just do that at like a centralized facility. So if we're going to be out in the desert making fuel in Nevada, Utah, Arizona, something like that, we might send all our fuel to a centralized facility to be kind of sorted into these various compositions for the Northeast or for the South and things like that. So you don't have to do that where you're making the fuel.
Okay. Nice. So if you could describe to the audience exactly what does the forge look like if you were to be standing directly in front of it. And your website does a good job of illustrating that, and I think Eric will probably embed this into this particular podcast so the viewing audience can see too. But could you just describe like what people would see?
Yeah, I mean, we kind of try and show the inside in the chapter 3 of our website about the Metaforge, where it shows the robots putting in the stacks.
Yeah.
So both the foundry and the forge, excuse me, are pretty much just stuff full of these hydrocarbon electrolyzer stacks. We call them Faraday reactors, named after a scientist named Michael Faraday. But essentially, it's just like if you want to get more range in a car, you put in more batteries, right? So if you want to make a lot of fuel, you put in more stacks. So a 40-foot container, if you open it up, it's going to be mainly stacks. If you go to like a foundry, which is going to be like a warehouse building, it's going to be mainly stacks. And there'll be some tanks and some pumps and some electrical connections. But it's mainly, that's what it is. It's just these electrochemical stacks.
And the fan is positioned where? Up on top?
So that's the direct air capture. So we can put that into a 40-foot container also, or you can make like a wall of like air capture. But generally ours looks a lot like cooling towers.
Okay.
So the idea is a cooling tower is designed to, is designed to contact air with water. Right. And that's kind of, we adapted that. So the 40-foot container we have now that we're building is about 200 tons of CO2 per year capability, and has a big fan in the middle on the top.
And all this stuff is powered off of renewable energy, wind farms or solar, correct?
Well, you could use any kind of electricity you want, but it just turns out the cheapest electricity in the world is from solar.
Exactly.
So if you're going to use electricity, you want to use the cheapest one. And for some people that's really important because they want it to be renewable, but for other people that just want the gas to be as cheap as possible, it turns out those are the same thing these days. That wasn't true maybe 10 years ago when electricity from solar was a lot more expensive and the wind was a lot more expensive. But now it's, if you're someplace that, for one thing, we don't connect to the grid. So these are off-grid solar connections. Off-grid solar farms. And if you're in a place that has good sunshine with no grid connection, today you can get less than 1 cent per kilowatt hour from these kinds of installations. And you're not going to get that kind of price with any kind of fossil input. So it just ends up that cheapest also equals renewable, which is great.
Absolutely. I think you mentioned on your website something about carbon density. Is that correct? When you're processing the CO2 and then you're making the fuel, your carbon footprint, carbon density is extremely low compared to the conventional refineries, obviously, because they consume a lot of power to produce the fuel that goes into our vehicles.
The oil came from a plant typically in the past. It's not dinosaurs. It's usually like algae or decayed plants or something like that. So it was CO2 that was in the air back then, but it's been on the ground for millions of years. And when you burn the oil, you put it back in the air. And so that can cause the planet to get warmer. And that can be really bad. So if you make the fuel from the air itself, then you're just going in a circle and you have no impact on anything going on with the climate. And that's really good. When we talk about density, we're usually talking about like energy density. So people use this term when they talk about what a battery can do versus what fuel can do. So the reason you can, if you want to go very far away on a plane, you can fly for 15 hours without landing. And that's because of how energy dense the jet fuel is.
Yeah.
Wouldn't be able to do that with a battery plane. That's not going to happen. So we talk about our fuels have really high energy density, the same energy density as diesel and jet fuel.
Mm-hmm. Yeah. So if you look at it, I don't know how to say this, Ragone plot, the energy and power is up on the upper right-hand side of the chart there, and the battery chemistries are between the lower left and halfway up the chart. So how efficient is your system as you making the fuel?
We think about efficiency in two ways. When you're using renewable electricity, what you really are not worried about is how much you use, because it has no negative impact on the environment. So you're not worried about trying to optimize it on that basis. Whereas if you're burning like natural gas, you want to use as little as possible because you're worried about that. So we think about cost efficiency. So in other words, if we're at less than 1 cent per kilowatt hour, then the major cost factor is your equipment. And so then we actually can dial the equipment to be more or less energy efficient, to be more or less cost efficient. So if we want to optimize towards energy efficiency, we could be like 60%. 60% of the solar electrons will turn into chemical energy in the fuel. But if we want to be like overall cheapest fuel, then it's more like 45%, 45%, because that ends up sort of optimizing where things are now for the capital of equipment versus the electricity.
Okay. Your only byproduct is oxygen, is that correct?
Oxygen, that's it. Yeah. So it's like having a massive forest, in electrochemically. We're doing the same job as trees. We're capturing CO2 and then emitting oxygen, which is pretty neat. And we also, because we have to filter the air going through our systems, we're actually cleaning the air of soot and particles too, because you have filters. So it's doing like an environmental service out there. If you're living next to one of these things, your air is better.
Oh, absolutely. Yeah. Do you have one of these units installed anywhere outside of your location yet?
We have our first commercial pilot, which is at our headquarters, and that's the only one today.
Okay.
So what we're doing is we're, actually this month we're trying to settle in on our first site for the first commercial project.
Nice.
And we're calling that first commercial project Project Lodestone, and that's going to be 100,000 tons of methanol per year made from off-grid solar. And we've already sold out that project for 10 years. There's actually a wait list on that project. So we'll start building that. The idea is to start building it next year and to try and finish in less than 2 years. And then we'll move on to the next scale, which is going to be like 1 million tons per year. We call that Project Lodestar. And that's going to be, that's also sold out for 10 years. So there's a lot of demand for this product because we can beat the price of the commodity market. So the fuels coming from these projects, expect them to cost less than if you were to buy methanol from the commodity market.
Have you received any pushback from the conventional refineries?
They're not worried about startups. I think that we don't need refineries in what we do. We make finished fuel products, directly. But the fuel market is massive. So we could go as fast as we possibly want to, and everybody who's got a job in a refinery now will still finish their careers out, right? But there is no future for the refinery.
So obviously your passion is not only the creativity and doing stuff that other people haven't done, but also saving the planet. Was that the principal driver behind starting this particular company with your team?
Yeah, I mean, when I was going to school, I was like, what do I want to be? I want to be an environmental engineer, which is kind of a new idea. We look back now, we think, oh man, maybe Benjamin Franklin was the first one because he invented this stove that was way more efficient at burning wood. But it's a real thing now. So environmental engineers, they think about desalinating seawater, purifying drinking water, cleaning air. And that just was really interesting to me. And I really like chemistry. I really like engineering. And so like I said, I went out into desalination first, my first company. And then I did membrane separations, my second company. It was also nanotechnology based. And then this one, but I guess it really appeals to me is the idea that it just adds this massive new capability to human society. The fact that you don't have to go find fuel anymore, you make it, is just a big transformation.
Yeah, somebody asked me probably 2 months ago, give or take, if I would be willing to do this podcast with you. And I said, well, tell me a little bit about the company. And the response from somebody was, well, they just make fuel out of thin air. Okay, so I'm skeptical, and I think a lot of people are, and until after they hear this podcast and do some research. Again, your website is fascinating with your storyline. And then when you read through it and you dig a little bit deeper, because we're all engineers here and we like to understand, figure out how things work, what you're doing makes a lot of sense. And you validated it. And I think I read where your technical readiness level is up around 9. Is that true?
Yeah, what that means is that there's no more development to do. Your commercial readiness. And in particular, I can dig into like kind of how people think about that from a chemical engineering perspective. In particular, what we're doing now is exactly what we'll do in a fuel foundry. So it's a full size electrochemical stack, no changes to it. There's just more of them in a warehouse like the one we have. The solar is in our parking lot. The solar is going to be around the building. Our director captures in the back of the building. The director capture is going to be outside. So everything's exactly the way it's going to be at a 100,000 ton scale, and there's no more changes that have to be made. When people are at TRL 7 or TRL 8, they've got a prototype that isn't really operating in the real environment. There's some differences that you still have to get through. We're done with all that. That's pretty exciting because it took us like 6 years to do it.
Yeah, yeah. You have reached out and run through the process with third-party testing, correct? And they validated everything that's part of the TRL levelness, readiness. But what did they look at, third party, to validate your fuel compared to competition fuel, fossil fuel?
So we early on we realized that we were doing something that was going to be hard for people to understand. It's really new. It's not very often that generally new technologies are created or that new chemical processes are created. So we looked for an engineering firm that we could bring in to do an assessment. They could come and see the fuel being made and can make their own assessments of our readiness and costs and stuff. So we chose a firm called Ramboll. That's a Danish engineering firm that's operating in the United States as well. And they're just very well regarded and very good at what they do. And we brought them in 2020 and had them look at all of our data and look at our systems. And at the time, they said we were TRL 6 or 7 back then. And so then we had them come back in again in 2024 and last year because we had kind of increased the size of the molecules we could make for them. So we showed them C1 to C8 alcohols. C8 is like octanol. So you could use that and you could blend that with gasoline, jet fuel, or diesel, for example. And we didn't ask for a new TRL assessment, and we haven't brought them back since. But we did get cost estimates. So they would say, okay, we think that if you make your ethanol, it's going to be like less than $2.20 a gallon, and then show kind of what's the commodity market for ethanol. It's like, hey, it's right in the middle or a little on the low side, and the same thing for a lot of our other fuels. And so when we talk about our low fuel costs, we're referring to those third-party assessments. And it was also really important that people know that we were being transparent about our technology. We weren't just like doing everything behind a black screen, but at the same time, we had to kind of think about the fact that this is a really valuable thing, and we filed patents on it. There's trade secrets around it. If other people knew how to do it, they would certainly want to do it, and so we had to kind of walk that line, and that's how we navigated it. So yeah, it was great to do that. We did that 2 times.
Yeah, I remember reading that on your website 2 times. Who are your partners, or who are the parties interested in using your fuel? Are you able to say that?
We're not actually. We're going to announce the partners once the shovels go on the ground on the projects, but we have them in LOI. So we have 3 major customers. We have one in aviation. We have one in plastics. So we're going to make carbon negative plastics, right? So you can actually imagine your luggage is made from air, and you actually are carrying air around in with your laundry.
Yeah.
I mean, so that's pretty neat.
Absolutely.
So we can make something called syngas, which is a really important gas, usually made from methane, that is used to make all kinds of things like luggage or adhesives. Like if you go to Home Depot, like many of the things that are in there were made from something like syngas. So we can actually insert ourselves into the existing kind of industrial base to make a wide variety of things. And one of our customers wants to do that. And then we have a maritime customer as well. But we're not announcing their names until we actually, got our site selection and we got a shovel on the ground.
I fully understand. Can you divulge perhaps the timing when the first shovel goes into the ground?
Well, we have to choose a site. We have to go get the project financing. We have to do all those things that are necessary.
Yep.
If things go as we'd like them to, we'd be putting shovels in the ground next year.
Nice. Very good. Is there any special takeaways you would like our audience to walk away from this podcast with?
Yeah, I would say that this is a very exciting time to be alive. I mean, there's some really big things happening. I mean, AI is a really, really big deal.
Oh, yes.
But I think that when you look back on this, that the Prometheus fuel technology, the ability to make a fuel that costs less than digging for energy in the ground, is going to be one of the things that transforms society for the better. Imagine like super abundant, super cheap energy, not having to pay gasoline prices that are going up and down all the time based on whether or not somebody's blockading a strait somewhere, right? You can have complete predictability on your fuel and not having to worry about whether or not you're just polluting your environment by using it. I think it's going to be one of those really major turning points, and I'm excited to be part of it.
I think so too. You're spearheading it. You're going to be one of those guys that have their own island, fly a helicopter too. And
I'll make my own fuel too.
Exactly, with a nice yacht. Pretty cool.
That's right.
Okay. Is there anything else you want to add to this podcast, Rob?
No, I think that's everything that we could talk about. I mean, the variety of things we're going to be able to fuel is interesting. Trains and boats and planes, and the fact that we're going to drive the price down because solar is getting cheaper and cheaper and cheaper over time. And also inflation. This is something that maybe people don't appreciate is that, we talk about gas prices being volatile, but they're also subject to inflation. So 10 years from now, that price for gasoline is going to be going up 2 or 3% every year. And it's going to be much more expensive. But if you were to build a foundry today and install the solar panels, it'll be the same price for 20 years, maybe 30. It depends how long the solar panels last before you have to repower them. So inflation protected, cheaper all the time. I mean, it's exciting.
So again, we're looking at a product that you're producing that going to fuels for vehicles, train, plane.
Power cities, factories,
power cities.
AI.
That's extremely important. They're power hungry. Those AI farms, materials, luggage, you name it, and spirits. I think that's probably of the three. That's the most important one.
And all made from air and electricity.
It's amazing. It's incredible. Okay. I ask one more time. Is there anything else you want to add before we wrap?
That's all I can think of to share.
Yeah, I think we hit all the key points I think that the audience wanted to hear. I think the most important thing is getting your name out there. And I hope a lot of people watch this particular podcast. Your team and yourself have done a wonderful, wonderful job to this point. Again, everybody needs to go look at their website. You want to say your website name, please?
Yeah, www.prometheusfuels.com.
There you go. And it's very intuitive and interactive at the same time. Rob, thank you very much for this podcast.
My pleasure. Thank you.
Everyone that's listening, thank you for joining us on Munro Live Podcast.